Welcome students into the new class of the physics. Today we are going to discuss about the gravitational acceleration. We know what is the gravitational acceleration, right? In the last session we had discussed about the gravitational force. The equation of gravitational force we can write as F is equal to G m1 m2 divided by r square. Okay, so this is the magnitude of gravitational force. If we write the gravitational force and if we take m1 as the mass of earth and m2 as the mass of some object, let's say some small object, okay, then we can write this equation as the gravitational force F is equal to G. Let us take mass of earth as me and the mass of small object is m, and let us take the radius of earth re square. So this is the equation of gravitational force which is acting on the object which is placed on the surface of earth. Like, let us take for example, this is the earth, right? And here is that some mass, okay, which is at re distance from the center of earth. Okay, now what is this force is actually? Is it the weight? Yes, it is the weight of this object on the surface of earth. So the equation of weight we write as W is equal to mg, right? So if we compare these two equations, then we get mg is equal to gme into m by re square. So if we cancel the mass from both the side, then the equation of g we get gme divided by re square. So this is the equation of gravitational acceleration due to earth. Okay, now we can see here in this equation, this g depends upon the radius of earth, right? That means if we go away from the earth's surface, then this value of g must be vary, right? So let us see how the value of gravitational acceleration is changing with respect to the distance from the earth's surface. Let us take, for example, the object is at some h height. Let us take this is object which is at some h height from the surface of earth, and the radius of earth we take as re, right? Now, so this equation will be modified like g is equal to gme. Now in the denominator we will take the total distance from the earth center, that is re plus h square, right? Now if this h is comparable to re or greater than re, then to find the value of gravitational acceleration we must use this equation. Let us call it equation number 1. So this equation can be used, let me clear here that this equation can be used when the distance is very large, that h is very large compared to re, or it is when it can also be used when it is comparable to re. But if the value of h is, let's say, very small compared to re, the value of re we know that it is 6400 kilometer, right? The value of re, let me write here, is almost 6400 kilometer, okay, the radius of earth. Now if we take the value of h, let's say for example 50 kilometer or let's say 10 kilometer, then this value is, we can say, the negligible with respect to the re. So we can take, if the h is very negligible than re, then in that case this equation of g will be changing. Let us see how. In that case we have to, let's say, modify this equation by using the binomial theorem. Wait here, what is the binomial theorem? Now let us clear then first of all what is binomial theorem. Let's say for example we have the form of function like 1 plus x raised to n. Okay, now in this case the right hand side, or we can say the simplification of this function, we will get the series, one series. Okay, we are not going to write the whole series here, but if we have the condition here like if the value of x is very less than 1, if we have this condition, then the value of this 1 plus x raised to n, we will have 1 plus nx. So what here we did is we have just multiplied this power with the second term, so we got 1 plus nx, right? Now let us check, is this condition is applicable here or not. See, this equation we can modify like this. Let me write here again that the equation of g is equal to gme divided by re plus h square. Now let me write this equation, let us call it g dash. This is the new gravitational acceleration at some height. So I have taken RE outside of the bracket. So this equation becomes like this. Okay. Now, sorry, here RE square should be. Now this GME divided by RE square, we can see here it is the original gravitational acceleration. See, GME by RE square is equal to what? It is the gravitational acceleration at the surface of Earth. So we can write here that G dash is equal to G by 1 plus H by RE square. Okay, if we take this denominator into the numerator, then the power becomes negative. So we can write here minus 2. Now let us check this second term. This H is very small compared to the RE. So we can write here this H is very small compared to RE. If the value of H is nearly about, let's say, 10 kilometer or 20 kilometer, like that. Okay, so in that case we can directly use the binomial theorem, which we already discussed right now. Okay, so let me write here G dash is equal to G into 1 minus twice H by RE. Okay, so this is the equation of variation of gravitational acceleration when it is at some negligible height h with respect to the Earth's surface. Okay, so let me tell you, this equation is very important equation from exam point of view also, as well as competitive exam point of view also, as well as 1 mark question point of view also. Okay, so we have to remember that the gravitational acceleration with respect to with respect to height, how it is going to change, that original G in bracket 1 minus twice H by R E. Okay, so these, again let me repeat, this equation is the very important equation. So let us keep up to here for today in this session. Okay, so the variation of gravitational acceleration with respect to the depth from the Earth's surface, that we will discuss into the next session. Thank you.